Alright, what's up guys? In this video we're going to pick up with some multivariable calculus. Going to continue with chapter 13, which is vectors in the geometry of space. So we're asked to consider the given points P and Q here. They want us to find an equation of the sphere for which the line segment PQ is a diameter. So the first thing is to write down the equation of the sphere. Alright, so recall that the equation of the sphere takes the form x minus a squared plus y minus b squared plus z minus c squared is equal to r squared, where r is the radius and a, b, and c are the center. So in our case, we're given these 2 points here, but notice that we're not given the center, so we need to find out what the center is. And so to do that, we're going to use the midpoint formula. So let me just quickly remind you what the midpoint formula is, and then we'll get right down to it. Alright, so recall that the midpoint formula, again, this is all going to be 3D. It's going to be x1 plus x2 divided by 2, y1 plus y2 divided by 2, and then z1 plus z2 divided by 2. Now we obtain x1, x2, y1, y2, z1, and z2. We obtain that from our points, of course, and it's just a substitution process at that point. And this will give us our center, which is what we need. So let's just go ahead. I'm sorry, that's 4 theta. It's supposed to be for PQ. Sorry. So let's go ahead and get that. So it looks like we're going to have 1 plus 3 all divided by 2. Pay attention to sign changes. So it looks like we're going to have negative 2 plus 4 divided by 2. Looks like we're going to have 5 plus negative 6 all over 2. Again, make sure you're paying attention to your sign changes. So it looks like we're going to get a center of, well, it looks like we're going to get 2, positive 1, and negative 1/2. Okay, so that's the center. All right. Now we need the diameter. So for that we use the distance formula. So remember our distance formula, d, is going to be equal to the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. Okay. And that'll give us what we need. So let's go ahead and substitute in. So looks like what we'll end up getting is the square root of. It looks like we're going to have 3 minus 1 squared plus 4 plus 2 squared, because remember the 2 up there is negative. We already got a negative in there, so just pay attention to those sign changes. And then this will be plus negative 6 minus 5 squared. Let's see what we get. So we should get the square root of 161, but I will obviously check just to make sure, and I highly encourage you to do this. It is nothing wrong with that at all. Just check and make sure that your answers are correct. So it's going to be 4 1.6. Yep, it's going to be 161, or the square root of 161 is what we'll get. Okay. So, with that information, we know that the radius of the sphere here is just going to end up being 1/2 multiplied by the square root of 161. Then we have the center. So for the equation of the sphere, all we got to do is plug in and simplify. I'll put that right there. So for our equation of the sphere, we'll go ahead and put that in. Alright, so it looks like we'll have x minus 2 squared plus y minus 1 squared plus z plus, now recall that it was a negative 1/2, so it has to be plus 1/2 now, and that was being squared, and that's going to be equal to 1/2 multiplied by the square root of 161 quantity squared. And we will of course simplify that, and that'll give us our final answer. So we'll go ahead and write our final answer down here. So our equation of the sphere here, when we clean this up, will be the following. So it looks like we'll have x minus 2 squared plus y minus 1 squared plus z plus 1/2 squared. And that's going to be equal to, well, if I'm squaring 1/2 and the square root of 161, well, if I square 1/2, again, I'll just have basically 1/4 because I'm squaring the 1 and the 2. And recall that if I square a square root, in this particular case, if I square the square root of 61, 161, I just get what's under it. So if we actually simplify this, we'll get 161/4, which is the equation of the sphere there, and our final answer. And that's how you solve it. So let me know if you got any questions. I'm going to be more than happy to talk about it. So I'll see you guys next time.